L'Hopital's rule is a rule that is for finding limits, and it's applicable if you're trying to find the limit of something that's in indeterminate form. So 0 divided by 0, or 0 to the infinity, or anything like that. It's applicable if the two functions, the numerator and denominator, are differentiable on an open interval that contains the value that you're taking the limit to. Assuming that the derivative of the bottom doesn't equal 0, then what L'Hopital's rule says we can do is simply take the derivative of the numerator and denominator separately, not the quotient rule, but separately, and then find the limit there. And you might have to take L'Hopital's rule a couple times in order to get out of indeterminate form. So here is an example. Limit as x goes to 0 of this. Well, the problem here is that x goes to 0. So we have indeterminate form, something divided by 0. L'Hopital's rule says that we can take the derivative of the top and the bottom, and the limit is going to be the same. So the derivative of the top is 2e to the 2x. The derivative of the bottom is 1. Well, as x goes to 0, e to the 2x goes to 1, so this is equal to 2. And if you were to graph e to the 2x minus 1 over x, you could see that indeed the graph does approach 2 as x gets closer to 0. Now, we're going to look at the limit as x goes to infinity of this. And you might look at this and say, well, how does L'Hopital's rule apply to this? We're going to do something a little bit unique with this. I'm going to say that y is equal to 1 plus 1 over x to the x. And I'm going to natural log both sides. Allowing me to bring the exponent down. And this is, if I took a limit of this right now, I get infinity times 0. That's not quite indeterminate form. What I'm going to do is I'm going to take the limit as x goes to infinity of the natural log 1 plus 1 over x divided by 1 over x. This is now indeterminate form. This would be equal to something over 0. And now L'Hopital's rule applies. So I'm going to take the derivative of the top and the bottom. And what I'm left with when I take the derivative, here's a side bubble. 1 over 1 plus 1 over x times, I have to use the chain rule, negative 1 over x squared. It's derivative of 1 plus 1 over x. Divided by the derivative of the bottom. Remember, we're taking the derivative of the top and the derivative of the bottom completely separate of each other. Those cancel, and I am left with 1 over 1 plus 1 over x. And now that's something I can figure out. This is equal to 1. But remember, I made this substitution up here. I wasn't taking the limit of this, I was taking the limit of its natural log. So if the limit of y, limit of natural log, was equal to 1, that means the limit of y, our original expression 1 plus 1 over x to the x, as x goes to infinity, is equal to e. So as x goes to infinity, this expression gets closer and closer to the value of e. The thing that people get thrown off with L'Hopital's rule is you're taking the derivative of the numerator and denominator separately. That's why I've said that a couple times. It is not the quotient rule. We are dealing with limits, not finding the derivative. This is a little bit different than what we've been doing in the calculus stuff. We have to go back to limits. Remember, we are not finding derivatives right now. This allows us to find more complex limits. So here's your assignment from your packet that you have from the calc book, 11 through 31 odds.